How can we fight light pollution? What is the future of spaceflight in these uncertain times? Why doesn't Venus lose its atmosphere without a magnetosphere? All this and more in this week's Question Show. It's time for the Question Show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into this week's questions. Jamie Orlando, how can Venus hang onto its atmosphere without a magnetic field? So here on Earth, the magnetic field is very helpful for keeping the lightest elements in our atmosphere, the hydrogen. But still, like Earth is losing tons of hydrogen and other light elements to space because of the solar wind every year. And in fact, like the mass loss from atmosphere roughly matches the amount of additional mass that gets added to the Earth from meteorites and stuff landing, dust hitting the Earth and getting added to our mass. But that's a totally different conversation. But the question you're asking is, well, okay, so Venus doesn't have a planet-wide magnetosphere that is protecting it in the same way that Earth is being protected. Mars doesn't have a planet-wide magnetosphere, and Mars lost most of its atmosphere. So why doesn't Venus lose its atmosphere? Now, I mentioned that the thing that you're losing is the lighter element. Hydrogen is the lightest element. It is the trickiest element, and it really wants to escape and get away. And so you've got this ultraviolet light that is coming from the sun. It is breaking up molecules in the atmosphere of Venus. The hydrogen is escaping out into space, being pushed away by the solar wind, and it's concentrating the heavier things that you get. Carbon, oxygen. And so you've got a very thick atmosphere of carbon dioxide on Venus. It is losing atmospheric mass. There is a tail of material that is coming off of Venus. It's just that it has so much material available that it's just going to take a long time. There's more nitrogen in the atmosphere of Venus than there is in the atmosphere of Earth. So there's just a lot of atmosphere at Venus for it to lose. M. Lacaud, do you think, given the current geopolitical climate, there is a chance in the next 5 to 10 years for a rise in interplanetary missions, or will there be cuts? So I'm recording this episode in the beginning of December 2024, and the answer is that we have no idea what's going to happen in 2025. When the Trump administration takes over the presidency, when you've got a House and a Senate that's aligned with Trump, with a Supreme Court that's aligned with Trump. Now, in general, space exploration and human space exploration and even science are politically neutral, that often people from across the aisle will come together to fund and support space exploration programs. And so for a lot of stuff, it's very clear what's going to happen to programs under the new administration. But in the case of space exploration, we don't know. And at the same time, there's a lot of space exploration that is happening from around the world. And so, the simple answer is we have no idea, right? The more complicated answer is why don't we look at the rest of the world first, and then we'll come back to the United States. Obviously, they're a big player. And so China, for example, is just moving as quickly as they can to establish a presence in the solar system. They've got a space station that they've launched and are adding modules to it. They're going to be adding a space telescope that's going to fly close to it very soon. They've been retrieving samples from the moon. They're planning on having humans set foot on the moon by 2030. And so you can imagine, let's say 2030, the United States has deorbited the International Space Station and has not built a replacement and has not completed building the Lunar Gateway, or maybe they cancel Lunar Gateway. We'll get into that in a second. Then the Chinese are the only people with a space station in orbit, and the Chinese are going to have humans setting foot on the moon. They're also planning their Mars sample return mission, and this is something that NASA looks like they're canceling or are going to come up with a new way for the Mars sample return mission to go forward. The Chinese are planning to send their mission, and we'll probably see the samples back on Earth in 2031. And then you've got the Indians, and India has been putting a lot of energy and investment into their human spaceflight program. It's expected that we're going to see people from India go into orbit before the end of the decade, and they're probably going to build their own space station shortly after that, and plans to send humans to the moon as well, which is really exciting because the Indian space program is very innovative, and they're making great strides. So definitely watch what they're doing. Europe is very tied to what happens with the US. There's a lot of missions that they work on together, like James Webb. In fact, when the Russians invaded Ukraine, the NASA pitched in on the Rosalind Franklin rover to help sort of get that mission to Mars. So you see a lot of collaborations between Europe, and they have no sort of separate plans, although they have plans in the works to develop a lunar village. So, who knows what the sort of the future of human exploration of the moon looks like from Europe. And so the big question, of course, is the US. There are a bunch of missions that are already on their way, right? We've got the launch of Europa Clipper, the launch of Psyche. Like, these spacecraft are already in space. Then you've got missions that are in the final stages of being completed. So you've got, say, the Nancy Grace Roman Space Telescope. You've got Titan Dragonfly, which is going to launch in 2028. And then you've got longer science missions, which are still in the planning stages. Things like the Habitable Worlds Observatory, which probably won't launch until the 2040s. And so you need this sort of continuous funding for these projects. And then sort of the elephant in the room is what's going to happen from the human space exploration side. Right now, NASA is stacking up the second Artemis mission, the Space Launch System built by Boeing. These things cost $4 billion a pop. And very soon, Artemis 2 is going to do a flyby of the moon with 4 astronauts on board. And then following that, you get the launch of Artemis 3, which hopefully is going to have humans set foot on the moon before the end of the decade and before the Chinese are able to complete their first mission to the moon. And so the question is, like, what could get cut? Like, on the one hand, you could imagine the sort of the cuttiest scenario where science programs are cut, where the Space Launch System is canceled, where exploration is then contracted out to various private contractors like SpaceX. You could imagine a situation where things go essentially as they had before, because there's a lot of political will. There's a lot of employees across tons and tons of different parts within the United States that are all depending on the Space Launch System and the current ways that we're flying in space, as well as the science and the missions and the development and all the contractors. Like, there's a lot of momentum in the current way things are done. And then what will probably be the most likely is that you're going to see priorities change. You're going to see some missions cut. I would be shocked if the Space Launch System survives another administration. Even if it does work and it does bring humans to the moon, it's incredibly expensive, and there should be less expensive ways to accomplish this. So this is a very long-winded way of saying that, for the rest of the world, they have their plans pretty solid. The US, everything is in flux. And we can have this conversation a year from now, and I'll be able to report on what happened. And until then, just watch, and, I'll let you know what actual concrete things happen. Tony Hobbs, if Sagittarius A star suddenly became an average luminosity quasar, would we see it from Earth? And if so, what kind of brightness would it have? The supermassive black hole at the heart of the Milky Way, Sagittarius A star. This is a supermassive black hole with 4.3 million times the mass of the sun. And it is not a quasar. A quasar is when a supermassive black hole is actively feeding, materials falling into it. It is blasting out all of this radiation, and it is visible. These are the brightest continuous objects in the universe. We can see quasars from billions of light years away, times just after the beginning of the universe. And yet we can't see the galaxy that's around them. We can just see the quasar. And so the Milky Way and most galaxies no longer have a quasar, but it might have been that the Milky Way had a quasar in the past. And the best chance for the Milky Way to get a quasar in the future is when Andromeda crashes into the Milky Way, or I guess Milky Way crashes into Andromeda. Anyway, when the Milky Way and Andromeda merge, then both the black hole at the heart of the Milky Way as well as the black hole at the heart of Andromeda will start feeding. They will get material, and it's entirely possible that they will turn into quasars. So what would that look like from the Earth? You're standing here, you're looking towards the center of the Milky Way. What would you see? You would see nothing. There is an enormous amount of gas and dust that is surrounding the area. And astronomers call this the zone of avoidance. And that dust is so thick that if there was a quasar at the heart of the Milky Way, you wouldn't see it because the dust is obscuring your view. But what if there was no dust? What would you see? You would see nothing, in that the quasar would not be pointed at you. The quasar would be pointed at some other direction in the sky. And so it wouldn't be a very bright object in the sky. I think I did a video about this many years ago, and I think the agreed brightness is like magnitude 8. So if you had a reasonably good telescope and you knew where to point it, and you had somehow removed all of the dust from the center of the Milky Way, then you would be able to see the quasar, but it wouldn't be that bright. Now, if it was pointed directly at you, which would be very weird because it should be aligned with the galaxy, but if it was pointed directly at you, then it would be brighter. But still, if and when the Milky Way gains a quasar in the future, billions of years from now, people on Earth won't be able to see it. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments, as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to our recent newcomers: Mark Fleischer, Mr. Fred Caddy, Kelly Baker, Lodwick Otto, Stefan Solar, and Socart117. Join the club at patreon.com/universetoday. Jesse Ray, I've been thinking about contacting my local town to see if I can convince them to take some steps to reduce light pollution. What are some things you would do or recommend if you were in my position? Light pollution is a scourge on our planet. And when you think about it, almost half of humanity can no longer see the Milky Way from their backyard. That most people who are watching the show, especially if you're in Europe, there's very few places you can go in Europe where you can actually see the Milky Way because of the light pollution from the cities. And I think that's a tragedy. And it doesn't have to be this way. That there are places in the US, I was in Tucson, and they have a really amazing dark sky ordinance for lighting. You have to use certain kinds of LED lights. You have to point them at the ground. There are places near Flagstaff where it's even more extreme because there are all these big observatories that are nearby. And they take the night sky very seriously. And it is possible to make a place that feels safe, lit as you walk around, and yet you're not pointing all of this sky, lights up into the sky for sky glow. So what are the recommendations? Well, there are some really good recommendation lists from the International Dark Sky Association. And, they provide the kinds of information that you're going to need to take to your local town to try and convince them to put in those kinds of ordinances. But in general, it is to point your lights, use directed lighting. So you're pointing it down at the ground in the places where people need to be able to see things, and not unidirectionally, and definitely not up into the sky. To turn them off and on at times that make a lot more sense, and to use a color spectrum that is better for the eyes, better for astronomy, better for seeing the night sky. And it's really nice. Like, I've been in places where the lights are low, but they're pointed at the ground and you can still see everything. And yet you can also look up and you don't lose your night vision, and then you can see the Milky Way above. And so it is definitely possible to be able to do that. And I think just like anyone who's watching right now, if you're part of a local government, if you want to try and make a change to bring astronomy into the reach of more people, this is the practical thing to do. And I always find it really funny because people are so mad about how satellites, potentially, the mega constellations, are going to be causing problems with the night sky. And they are. Like, no question, they are going to be causing light pollution, this kind of general sky glow. But it is, it doesn't hold a candle to the light pollution that has already happened from people pointing their lights up. And we got these lower power LED lights, and the thought was, okay, that's going to bring light pollution down. But in fact, with the rise of LED lights, light pollution has gone up, that people are using the power savings to just put out more lights and cause more sky glow. And this is all moving in the wrong direction. So get involved. Find out where your nearest dark sky preserve is. Go see what the Milky Way is supposed to look like. Go check out the International Dark Sky Association, find their recommendations, and then bring these issues up with your local government. And I think most people love space and would love to be able to see space better. And, a lot of times it's never occurred to them that these are things that we could restore. So good luck. Skuckix23. Isn't the crisis in cosmology a blessing? Both types of measurements should be accurate, but they don't overlap. Isn't this the best pointer for scientists on what to look for? Yeah, the crisis in cosmology is a terrible name because crisis feels like it's a thing that's bad, right? That, oh no, there is this crisis that if we don't solve this problem, then the universe will be destroyed. Cosmology will cease to exist, but it's nothing like that. It's that on the one end of the spectrum, when you measure the distance to Cepheid variables and you measure the distances to type 1a supernova and you use that to calculate the expansion rate of the universe, you get one number with a error bar of a certain size that you're comfortable with. And then when you measure the same kind of thing, but now you're measuring from the cosmic microwave background radiation, which is the oldest light in the universe, you get a different number. And the numbers are very close. And it used to be that their error bars overlapped, and so people assumed, okay, it's some number in between. But now the error bars no longer overlap, that both are so precise, and yet they are not the same answer, that this has caused the Hubble tension, the crisis in cosmology. And this is incredibly exciting, that this is the kind of thing that most scientific fields would just love to have this problem, because you're exactly right that because you have different methods of measurement giving you different answers, then you can start to track where this divergence started to happen. Why is the change in the expansion rate of the universe happening over time? Why was it different in the beginning than what it is now today? And then the possibilities are that it's measurement error. And, some of the best people in the world are working on this question. I've got an interview with Adam Rees where we talk about the level of effort and energy they've gone into to confirm the Cepheid variables. And most recently, he's then gone on and confirmed the type 1a supernova. And then you look at how exquisite the measurements to the cosmic microwave background are from the Planck mission, that this is all going really well. And fortunately, there's a lot of really cool new surveys that are coming up that are participating in this. So for space, you've got the Euclid mission, which the European Space Agency launched a couple of years ago. And we got some initial data from them, but we're still going to be a couple of years before we get their full data set. And they are measuring, they have sort of two instruments on board Euclid. One is to measure with visible light, they're measuring the shape of galaxies. And they're using that to try to see the amount of gravitational lensing that is happening to these galaxies over time. Where is the mass distribution over time? And then the other thing is they've got an infrared instrument that allows them to measure the chemical composition of the galaxies. That helps them figure out how far away they are moving away from us. This is going to be supplemented by the Nancy Grace Roman telescope, which launches in 2027. And then we've Vera Rubin, which comes online in just a couple of months from now. And it's going to be measuring type 1a supernova happening across the universe, things like that. And then something that you're going to start hearing a lot in the next couple of months, we're going to do a ton of reporting on this, is there's the DESI survey, the Dark Energy Survey Instrument survey. And this is very similar to what's being done with Euclid, this measurement of the expansion of the universe, the distribution of dark matter, dark energy over vast periods of time. And you're seeing some really interesting results that are coming out of it. Like, people are seeing support for the idea that there's some connection between black holes and dark energy, although other people are very skeptical, and it's a very out there idea. And yet there is some kind of correlation. You're seeing very good tests of modified Newtonian dynamics, this alternative theory for dark matter called MOND, and like the news isn't good. Like MOND is probably going to lose favor with the astronomical community based on the DESI survey. But again, this is all very new. And so it's this sort of vibrant time of a lot of really interesting ideas and the observations that they can use to back up the various theories that they have for what's happening in the universe. And so as a journalist, it's like, I don't know, I'm trying to think of a sports metaphor, but it's like the Super Bowl. Like there's something really exciting going on right now. And there's a lot of really interesting, meaningful progress that's going to happen. And so for you watching, I hope you really enjoy it, that I hope you will, you understand the mystery. You appreciate the different ways to try to explain it. You're going to watch as each of those different methods is attempted to try to make some kind of progress. You're going to see as the scientific consensus comes together on what appears to be the answer that best matches the evidence that's been found so far. And then you're going to see, hopefully, what were mysteries in the past start to become understood, and yet you're going to see more questions pour out of that. That's the scientific method. That's why I find this all so entertaining. And this is going to be one of the most entertaining things that I think we can all watch in space and astronomy. All right, thank you everybody who asked their questions in the YouTube comments, as well as everybody who joined for the live stream. This is the second part of the European time stream, and it went great. I had so many great questions. Stuck around for the whole 2 hours. We could have gone for 20 hours. It was super fun. So I think we're considering this a huge success, and we will be back next with the Pacific time, then the Asian stream, then back to Pacific time, then European stream. This is the new cycle. So we'll try and make the thumbnail match the stream that we're going to be doing. So just keep an eye on that. All right, I'm going to talk about another way that you can get your questions answered. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew Gross, Bear Lake Roofing, David Giltonan, David Matz, Dennis Alberti, Dustin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, SpiderSwap.io, and Stephen Filer Munley, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. Every time we do the live question show, we go for 2 hours. And then the first hour, we get about 12 to 15 questions that turns into the 2 question shows that we publish every week. Then we stick around and we do overtime. But at the end of every show, there are like 100 unanswered questions that I just didn't have time to get to. People always ask me, well, how do I choose the questions? Am I choosing questions just for the patrons or people who donate in chat? But no, it's entirely me trying to make the best show that I can, trying to answer the best, most interesting questions, the ones that I think provides the most information to the audience. But there is another question show that we do every month. That is the patron question show. And so the way this works is on the 15th of every month, I put out the call for the patrons to send in their questions. You all send in your questions. I do a bunch of research. Anton does a bunch of research. And then we get together and we do the show where we answer all of the questions. And so far, we've been able to answer every single question that we get. And sometimes the show runs 3 hours, 4 hours. I'm imagining it'll end up being a lot longer. And that's fine. That's why we do this for the patrons. So I'm about to put out the call for the next patron-only question show. And so if you want to get your question in, you've got a couple of days. I will send out the call on the 15th. So make sure that you become a patron before the 15th, and then you will get the call and you can respond, and I will answer the question in the next patron-only question show that goes out on our special podcast feed that's only available to patrons. All right. We'll see you next time.